My name is Johan Högnäs. I'm the Chief Geologist of Nordic Iron, and today I will be presenting the updated mineral resource estimate for our Blötberget and Väsmanfältet deposits. I will also present the ore reserves for Blötberget and discuss exploration targets and exploration upside for the project as a whole. There's no news on Högsberg today, but this prospect still remains in our portfolio for future investigations.
So this graph shows how we've effectively been able to grow the Blötberget in situ mineralization through exploration drilling. Since our last published study in 2019, we have increased the total mineralization by 41%, from 67 million tons to 94 million tons.
This increase is the result of the drilling that we have been carrying out in Blötberget over the past 1.5 years. Let's have a look at that drilling in detail. In the beginning of 2025, in a collaboration with Smart Exploration Research Center, we used seismic surveys to delineate the ore body to much greater depths than what had been confirmed by drilling thus far. In this process, we defined a drill target about 900 meters down plunge beyond the known mineralization at the time. That's the red line in this image, the red drill hole. We drilled this target and we successfully hit 19 meters of high-grade hematite mineralization, averaging around 55% iron. Following that success, we conducted an extensive exploration drilling campaign combined with some infill drilling to improve the knowledge of the deposit and to make sure we could report as much as possible in the measured and indicated category. Most of the exploration drilling was focused on filling in the gap between the known mineralization and the drill target hit, but some shallow drilling was also done to the east of the old open pit. We also tested the eastern edges of the mineralization, which showed that the mineralization seems to pinch out in this direction towards the east. These are some examples of quite typical mineralization we have encountered in this deep drilling program. Massive to semi-massive magnetite and hematite, sometimes mixed with each other, as can be seen in the drill core in the middle in this picture. Towards the end of the program, we had the best drilling intercept on the project to date when drill hole number 35 hit 2 lenses of massive magnetite, in total 45 meters, averaging 50% iron.
So the end result of this drilling campaign was an increase with 27 million tons compared to the targeted 35 million tons, which is a substantial 41% increase of the total in situ mineralization. The majority of the additional tonnage is derived from the deeper portions of the deposit. This is in situ mineralization, meaning that it has been reported as metal content occurring in the rock where the rock is located in the ground, without applying proper mining constraints. In the industry, we call these constraints reasonable prospects of eventual economic extraction, or RPEEE. It means that we have to properly apply a mining method, metallurgical parameters, metal prices, processing parameters, etc., to show that it is reasonable to assume that mining of this resource can be done sometime in the future. A RPEEE MRE therefore logically contains less mineralizations than an in situ MRE.
Applying these RPEEE criteria to Blötberget results in a total mineral resource of 58 million tons. Almost everything, or 56 million tons, is reported as measured and indicated resources. The previous MRE only reported in situ resources, so a real comparison on development of RPEEE MRE is not possible. Anyhow, what really matters at the end of the day is the amount of mineral reserves, in other words, ore, that the resource leads to. Blötberget is a Kiruna-type iron oxide apatite deposit, which means that in addition to iron ore, we also have apatite and rare earth elements in the ore. The apatite and rare earths were ignored in the last mineral resource estimate because they were not considered to add material value at that time. But the world, particularly in terms of resource availability and energy production, has changed since then, and especially rare earth elements are very much in the spotlight right now, as most people are aware of. And this is precisely the reason we decided to include apatite and rare earths in this update of the resource estimate. And in this maiden resource estimate for apatite and rare earth elements, we are reporting 30 million tons containing 0.47% phosphorus and 0.072% total rare earth oxides, all as inferred resources. It's important to note here that since we don't have rare earth analysis from all of the drill holes in Blötberget, only part of the Blötberget mineralization is included in this resource estimate. The mineralogy of these elements can be quite complex, but over the past 2 years we've been conducting mineralogical test work, so we have a pretty good idea of where the light and heavy elements occur and with which minerals each element is associated. It's also important to note that in the next phase we will be analyzing more of the drill holes in Blötberget, and so in the next update then we can cost effectively increase the mineral resources for the rare earths and apatites. The ore reserves in Blötberget are reported at 55.7 million tons at 36.1% iron, and we can conclude that nearly all of the measured and indicated mineral resources have been converted to reserves. The reserves have also increased by 63% compared to the last study made in 2019, and this increase has had a great impact on the economics of the project. So moving over to the Väsmanfältet prospect, which consists of 3 separate ore lenses, as you can see in this picture: Finnäset, Lyviksberget, and the volumetrically most significant Väsman South. And Väsman South is located completely under Lake Väsman. Nordic Iron hasn't conducted any drilling in the Väsmanfältet since 2012, when the company drilled 20 drill holes at almost 7,000 meters. These drill holes, plus a number of historic drill holes, were used in this MRE update. The total reported tonnage of Väsmanfältet is 46.7 million tons, and the vast majority of that tonnage is coming from Väsman South. Iron grades are a little bit lower compared to Blötberget, sitting just below 36% iron. And this mineralization is quartz-banded iron oxide mineralization, so no known apatite or phosphorus minerals in this deposit, nor rare earth elements. It's important to note that the Väsmanfältet prospect is much less developed than Blötberget, and that all tons here are reported in the inferred category. Nonetheless, the Väsmanfältet prospect is classified in accordance with the RP-EEE constraints. In the next phase of drilling, we will be looking to upgrade the current Väsmanfältet resources to measured and indicated, as well as adding new inferred material. There is big exploration potential in Väsmanfältet, and I will discuss this a bit later. So this is the combined mineral resources of the project, with both Blötberget and Väsmanfältet included. 27 million tons measured, 29 million tons indicated, and 49 million tons inferred, for a total of 104.5 million tons. As you can see, Blötberget accounts for a bit over half of the tonnage, about 58 million tons, and with a slightly higher iron grade, around 42% iron compared to Väsmanfältet. In conclusion, we have RP-EEE constrained mineral resources in both Blötberget and Väsmanfältet, but mineral reserves only in Blötberget. The reserves in Blötberget plus the mineral resources in Väsmanfältet contribute to the life of mine for the Blötberget-Väsmanfältet project. In Blötberget, we also have recorded an inferred mineral resource for apatite and rare earth elements. So now we've come to the exciting part, the exploration upside. We have defined the exploration targets and early stage prospective targets as well. The definition of an exploration target, according to the York Code, which we are following, is an exploration target is a statement or estimate of the exploration potential of a mineral deposit in a defined geological setting where a statement or estimate quoted as range of tons and a range of grades or quality relates to mineralization for which there has been insufficient exploration to estimate a mineral resource. So in other words, you have to be able to link the exploration target to the existing mineral resource somehow. And the exploration target has a higher level of confidence than the prospective targets. I think this will become more clear when we have a look at the Väsmanfältet a bit later. But now we'll start by looking at Blötberget. I already mentioned that we have been drilling quite aggressively in the down plunge direction of the mineralization, which has added a sizable tonnage to the resource base. At this moment, we're not planning to go any deeper due to both geotechnical and mining economic reasons. The deeper you go, the more expensive it gets to mine the ore, which means that it gets more difficult to find material of high enough grade to include in the ore reserves. Instead, the deeper targets are normally drilled out once you have the mine in production and easier access with declines and production drift, etc. I also mentioned that we have drilled the lateral edges of the mineralization and that the mineralization pinches out towards the east. This doesn't, however, mean that the area marked out in red color here in this image is barren. We know that the mineralization continues as quite a thin seam in the eastern direction, closer to surface. And sometimes this seam thickens out. In geology, we talk about pinch and swell. Many of these thicker sections have already been mined out historically, although not to very great depths. For example, in the historical mine in Väsmanfältet, which is located 1 kilometer from Blötberget, almost 1 million tons was mined down to a depth of 280 meters. So it is quite likely that this mineralized seam continues at depth. And if it thickens out, it could be interesting from a mining perspective. So we would probably use geophysics in the form of seismics to investigate this area first and then follow up with drilling if we find anything interesting. We also want to investigate the western side, especially at depth. It's marked here in orange in this image. We have done seismics in this area and the results are being interpreted at this moment. And the same thing here, if we see something interesting in the seismic data, we would want to follow up that with drilling. So in Blötberget, we do have some areas that we want to investigate going forward, but we haven't defined an actual exploration target in terms of tons and grade. And these areas should be considered more prospective targets. In Väsmanfältet, on the other hand, which has significant exploration upside, we have defined exploration targets as well as several prospective targets. It's been known for a long time that there's a major magnetic anomaly below Lake Väsman and we believe that the current mineral resource only reflects part of that anomaly. This map from the Swedish Geological Survey shows the magnitude of this anomaly compared to Blötberget. So we believe there's much more mineralization to be found under the lake. We've used geophysics to model a possible magnetic mineralization envelope, which we have used as a basis for target generation. It's important to note that geophysics is only an exploration tool and that no real numbers in terms of tonnage and grade can be obtained with geophysics alone. We have used modern and historical drill holes, geophysics, and the current mineralization model to define 2 exploration targets and several prospective targets shown in this image. As you can see, the range of possible tonnages for the exploration targets is very large, between 8 and 80 million tons. This range depends on your assumptions. For example, the thickness of the ore lenses that you expect to find. The 2 exploration target lenses in this image are colored in blue and green, and you can see they are located closer to the known mineralization. And they're supported by singular drill holes. So their level of confidence is higher than the prospective targets. These prospective targets are located further away from the current model and any hard data. The prospective targets are colored in red in this image. This means that for the exploration targets, we have modern and historical drill holes plus geophysics supporting the estimation, while only geophysics and historical drill holes support the prospective targets. And that brings me to the last slide, which is a summary of what I have been presenting here today. There is more in-depth information on our webpage, so I invite you to visit us at nordiciron.se. Thank you for your time.